In this video, we're going to create the script for our player character. Before we begin writing our player script, we're going to add a few things to our game manager that our player script is going to make use of. Let's open the game manager and monodevelop. In game manager, the first thing that we're going to do is we're going to add a public variable of the type integer called player food points and initialize that to 100. The next thing that we're going to do is declare a public boolean called player's turn, which we're going to initialize to true. We're going to set player's turn to hide in inspector, which means that although the variable will be public, it won't be displayed in the editor. Next, we're going to add a public function that returns void called gameover, in which we're going to disable the game manager. Let's save our script and return to the editor. In our scripts folder, we're going to choose create, C# script, and we'll call this one player. We'll open it in monodevelop. Our player class is going to inherit from the moving object class we wrote previously instead of from the default mono behavior. The first thing that we're going to do in player is declare a public integer called wall damage and set it to 1. Wall damage is the damage that the player is going to apply to the wall objects when it chops them. We're also going to declare two other public integers called points per food and points per soda. These are going to be the number of points added to the player's score when they pick up a food or soda pickup on the board. Next, we're going to add a public variable of the type float called restart level delay and initialize it to 1. We're going to declare a private variable of the type animator called animator. We're going to use this to store a reference to our animator component. We're also going to declare a private int called food, which is going to store the player's score during the level before passing it back to the game manager as we change levels. We're going to add the protected and override keywords to our start function. We're doing this because we're going to have a different implementation for start in the player class than we have in the moving object class. In start, we're going to get a reference to our animator component using getComponent. Next, we're going to set food to the value of player food points, which is stored in the game manager. We're doing this so that player can manage the food score during the level and then store it in the game manager as we change levels. Next, we're going to call the start function of our base class moving object. We're going to declare a private function that returns void called onDisable. OnDisable is part of the Unity API, and what it's going to do is it'll be called when the player game object, in this case, is disabled. We're going to use it to store the value of food in the game manager as we change levels. We're also going to declare a private function that returns void called checkIfGameOver. CheckIfGameOver is going to be simple. We're just going to check if our food score is less than or equal to 0, then we're going to call the gameover function of game manager. The next thing that we're going to do is declare our attempt move function. We're going to declare attempt move with the protected and override keywords, and it's going to return void. It's also going to take a generic parameter t, which is going to specify the type of component that we're expecting our mover to encounter. Attempt move is also going to take two parameters of the type int called xdir and ydir for x direction and y direction. The first thing that we're going to do in attempt move is that we're going to subtract 1 from the player's food total. This means that every time the player moves, they're going to lose 1 food point, which is one of the core mechanics of the game. Next, we're going to call the attempt move function of our base class moving object. We're going to pass in our generic parameter t along with our integers x direction and y direction. Next, we're going to declare a raycast hit2d called hit, which is going to allow us to reference the result of the line cast done in move. Since the player has lost food points by moving, we're going to call the checkIfGameOver function to check if the game has ended. Finally, we're going to set our player's turn variable in the game manager to false to say that the player's turn has ended. In update, we're going to check if it's currently the player's turn using the Boolean that we created in the game manager. If it's not the player's turn, we're going to return, meaning the other code that will follow will not be executed. Next, we're going to declare two integers called horizontal and vertical and set them to 0. We're going to use these to store the direction that we're moving either as a 1 or a -1 along the horizontal and vertical axes. The next thing that we're going to do is get some input from the input manager, cast it from a float to an integer, and store it in our horizontal variable that we declared. We're going to do the same thing for the vertical axis. Currently, the movement code that we're writing is going to be based on a keyboard or controller input for a standalone build of our game. Later on, we're going to write a version of our movement code which will take mobile or touchscreen input. The next thing that we're going to do is we're going to check if we're moving horizontally, and if so, we're going to set vertical to 0. We're going to do this to prevent the player from moving diagonally. We're then going to check if we have a non-zero value for horizontal or vertical. If we do have a non-zero value, meaning we're attempting to move, we're going to call our attempt move function. When we do, we're going to pass in the generic parameter wall, meaning that we're expecting that the player may encounter a wall, which is an object that it can interact with. You'll remember that when we wrote moving object, we gave the attempt move function the generic parameter t. This is so that we could specify what component we expect to be interacting with when we call the function. In this case, from the player script, so that we can specify we expect to be interacting with a wall, or in the case of the enemy script, we can specify that we expect to be interacting with a player. We're also going to pass in horizontal and vertical as parameters, which are going to be the direction that the player is going to attempt to move in. The next thing that we're going to do is write an implementation for onCan'tMove. You may remember in moving object, we declared onCan'tMove as an abstract function without any implementation. Now we're going to define that implementation for the player class. OnCan'tMove is going to be a protected override function that returns void and takes a generic parameter called t, as well as a parameter of the type t called component. Note here that we're using a lowercase c for component. In the case of the player, we want them to take an action if they're trying to move into a space where there's a wall and are blocked by it. The first thing that we're going to do is we're going to declare a variable called hitWall of the type wall, and we're going to set it to equal the component that was passed in as a parameter while casting it to a wall. Next, we're going to call the damageWall function of the wall that we hit. We're going to pass in our variable wall damage for how much damage the player is going to do to the wall. The last thing that we're going to do is we're going to set the player chop trigger of our animator component that we stored a reference to earlier. We're going to do this by passing in the name of the parameter we want to set as a string. The next thing that we're going to do is we're going to declare a private function that returns void called restart. All we're going to do in here is reload the level. We're going to call restart if the player collides with the exit object, meaning that we're going to the next level. In restart, we're going to call application.loadLevel, passing in the parameter application.loadedLevel, meaning we're going to load the last scene that was loaded, which in this case will be main, which is the only scene in the game. In many games, to load another level, we would load another scene. In this case, we're restarting our main scene because our levels are being generated procedurally via script. Next, we're going to declare a public function that returns void called loseFood, which takes an integer parameter called loss. LoseFood is called when an enemy attacks the player. Loss specifies how many points the player will lose. In LoseFood, the first thing that we're going to do is set the player hit trigger in our animator. Next, we're going to subtract our parameter loss from the player's food total. Lastly, we're going to call the check if game over function. Because our player has lost food, we want to see if the game is ended. We want to give the player the ability to interact with the other objects on the board, namely the exit, soda, and food objects. We're going to do this using onTriggerEnter2D, which is part of the Unity API. We're going to declare a private function that returns void called onTriggerEnter2D, passing in the parameter of the type collider2D called other. You'll remember that we set our exit, food, and soda prefab colliders to isTrigger. And so what we're going to do is we're going to check the tag of the other object that we collided with to see first if it's tagged exit. If the tag of the other object is equal to exit, we're going to invoke our restart function that we declared, passing in our restart level delay, in this case 1 second, so that we can call that function 1 second after we've collided with the exit trigger, meaning that there's going to be a 1 second pause, and then we're going to restart the level. Since the level is now over, we're going to set enabled for the player to equal false. Next, we're going to check if the other object's tag is equal to food. If that's the case, we're going to add food points, and we're going to set the object that we collided with, the food object in this case, to inactive. Lastly, we're going to do more or less the same thing for our soda object. And there we have it. That's going to allow our player to use the core mechanics of the game. We're going to add a few other things to this script later on, but for now, let's save and return to the editor. In the editor, we're going to highlight our player prefab, go to Component, Scripts, and add the player component that we just created. We're going to set the blocking layer variable to blocking layer, and so that looks good. With that done, we have some of the core interactive functionality in place for our game. We're going to return to the player script to add UI elements, audio, and our mobile controls. In the next video, we're going to start setting up the animation controllers for our enemies.